Here we're going to work through another mixture type of problem. So if we look at the problem statement, it says we have aluminum in a 0.764 gram sample of unknown material. It's precipitated as aluminum hydroxide and then converted to something else. So I think it's helpful in these types of problems to kind of draw just a picture or diagram showing what's happening, what you're starting with, and what the process is looking like. So for this one, it says that we start with a sample that's an unknown material that has aluminum in it. So I'm just going to make a circle with a question mark in here. And the mass of this is 0.764 grams. And this is unknown, right? We don't know exactly what this is, but it is aluminum plus some other stuff. So we're going to take this sample, we're going to convert this or precipitate this, so it's going to react or come out of a solution to aluminum hydroxide. Aluminum hydroxide just looks like this. And then we're going to convert that to aluminum oxide. So aluminum oxide is just Al2O3. And then it says that we're going to end up with 0.127 grams of this aluminum oxide. So we don't know anything about how much of this we have. And we do know how much we started with, but I don't know how much aluminum was in that original amount. And I know how much aluminum oxide we have at the end. It's always good to recognize what the goal is, what you're trying to find. So in this one, we're trying to find the mass percent of aluminum. So I like to just write that out somewhere, right? My goal. So the goal here is mass percent of aluminum. So this means we need a mass of aluminum over a total mass times 100. And we're looking for the mass percent of aluminum here, right? So I'm looking for this aluminum in that whole thing. So if I look at this goal, in this goal, this bottom number here, this total mass, this is that number up top. So this is the total mass of this unknown sample that I have. So that's that 0.764. And then up top, I want to find the mass of this aluminum here. So really in this problem, the thing I'm after is this mass of aluminum here. So this is what I need. So we need to find this here. So here we go. So we need this. Okay, so how are we going to find that? So we want to look back up at our little schematic to see what's happening. So in this process, I can recognize that all of the aluminum that is here ends up in the aluminum oxide. So we always make the assumption that everything goes to completion and everything reacts as it would ideally. So all of this aluminum shows up here. I don't know anything about this, but I do know then also that all of this aluminum here should show up here. So if I can figure out how much aluminum, just aluminum, is in this last piece, in this last amount of aluminum oxide, I should know that all of that aluminum had to have come back from here. So if I can figure out the amount of aluminum in this product or this final piece of the process that we're looking at, that is going to be equal to the amount of aluminum that we started with, and that'll be the number that I want here. So in this particular problem, we're just looking for mass of aluminum here. So I'm going to set this up. We're looking for grams of aluminum, and we're starting with 0.127 grams of Al2O3. So I'm going from grams of something to grams of something else. So I'm going to set this up to first find moles of my Al2O3, and the molar mass here is 101.96. This is for 1 mole. Okay, then I can go from moles of the Al2O3. So I know that for every 1 mole of aluminum oxide, I have 2 moles of aluminum. And then for every 1 mole of aluminum, we have 26.98 grams of aluminum. So I've used my conversion factors. We did molar mass. We did a mole to mole ratio that was based on just the formula itself. And then we did molar mass of that aluminum. So we plug all of that into our calculators. We're going to end up with 0.0672 grams of aluminum. So all we need to do now, that was the goal that we started with. So remember, if I had 0.0672 grams of aluminum here, then I had to have also had that same amount or same mass of aluminum here. So we're going to just plug these guys back into this equation here. So I've got 0.0672 over that starting amount, 764 times 100, and we end up with 8.8%